numbers on that. Blow. We have to improvise. I don't have the mouthpieces. We just use some of that. We can wrap a piece of paper towel around, use some of the isopropyl alcohol and wipe it off, and put a piece of paper towel. It's fine. You know, I'll blow into it. You know, you're not going to catch anything. And you can wipe it like that, put a piece of paper, and blow into that thing and see what you get. All right, but anyway, there's the vital capacity. Now you need to remember this right here. Highlight that right there. Vital capacity. Here's vital capacity. Here's vital capacity. In other words, it's equal to inspiratory reserve plus tidal volume plus expiratory reserve. That's what vital capacity is equal to. And that normally, some of you guys are going to get some real good numbers there. That's been my experience. Some of you guys are going to get some real, I say guys, will normally get a little bit better readings than the girls on this. And so the number that normally is from 45 to, I'd give anything if mine would be 5,500. I don't get that. I'm not getting good numbers there like I wish I would get. Some of you guys are going to get some good numbers on this. You're going to get some real good numbers on this. All right, so that's the normal. That is it right there. Now, I also like to mention this. Residual error. Y'all know that residual error has been, what do you think? Let me ask you this. Now, this is not a real pleasant subject. This is not a pleasant subject. But what do you think? What do you think are some of the culprits in bad breath? Halitosis. Now, what other than onions and garlic and what do you think? And bacteria in the teeth, bacteria on the tongue, and so forth. What are some of the? What's another? Okay, one thing that has been attributed to bad breath is residual air. Residual air not being turned over enough. How can you turn residual air over? Again, that magic word, exercise. In other words, if you increase the respiration rate, this helps to keep the air fresh and not become, quote, stale. But residual air, quantity of air that's left in the lung after the maximum expiration. You and I are always going to have some air left in the lungs, just like we're always going to have some blood left in the ventricles. We're also going to have some blood left in the ventricles after the ventricles go into systole. So that's residual, about 1,200 cc's left. Now, keeping that turned over, possibly, so I've read, might be one of the contributing factors. There's several contributing factors for bad breath, though. There's several. You know, coffee, for one thing. You know, bacteria and so forth. It's a good idea sometimes when you brush your teeth, flossing teeth. That helps. Flossing helps. Brushing the tongue helps because of the bacteria. And so all that helps. And we've all, you all, you know what I'm talking about with this. You know exactly what I'm talking about with all that stuff. But anyway, there's that right there. Transportation, okay, now right here, I gave you a handout. Everybody getting a handout on carbon dioxide transport? We're about through with all this stuff. Everybody, Edgar, did you get one?
No.
Okay, I just put this in your note material. You have this in your notes, but I have a little diagram on here. Pass it back to Edgar. Anybody else not get one of these? That we're going to be getting to. The oxygen transport is pretty simple. Oxygen enters our blood and it dissolves in blood. It dissolves in plasma. Now, here's the deal. Let me show y'all. This is kind of where hemoglobin comes in. Now, notice this. Now, follow this. Don't let this confuse you. Follow it. Let me click this down. All right, now look at this. When 0.5 mLs of O2, that's not much, has dissolved in 100 milliliters of blood, the partial pressure of oxygen of blood equals the partial pressure in the alveoli. Okay, that's 0.5. Now, cells don't need 0.5 mLs. They need about 20 mL. Look at this. Cells need 20 mLs, not 0.5. 0.5 is a heck of a lot less than they need. 0.5 ain't nothing. They don't need 0.5. They need 20 mLs per 100 mLs of blood. 20 mLs of what? Oxygen per 100 mLs of blood. But when 0.5 mLs of oxygen has dissolved in 100 mLs of blood, the PO2 of blood equals the PO2 in the alveoli. That won't cut it. That won't cut it. I mean, we die in a heartbeat. That won't get us. We'd be hypoxic and we wouldn't have blood. We wouldn't have oxygen. All right, so here's the deal. Here's where hemoglobin comes in. 1 gram of hemoglobin carries 1.34 mLs of O2. That's, you gotta remember this. Let me see, it's gonna be on the next deal. 1 gram of hemoglobin. Therefore, most oxygen leaves the plasma and combines with hemoglobin. Now here's the deal. 1 gram of hemoglobin, now you need to remember this. This you gotta know. 1 gram, this is where your hemoglobin count comes in. 1 gram of hemoglobin carries 1.34 mLs of O2. Now, if you have, okay, now look, what did that slide say up there? It said right here that cells need 20 mLs of O2 per 100 mLs of blood. All right, now some of you, let's say that your hemoglobin was 12. All right, if your hemoglobin is 12, if you got your phone with you with your calculator, multiply 12 times 1.34. Multiply 12 times 1.34. 12 times 1.34. What did you get, Shasta?
16.08.
16.08. Is 16.08 20? No. Okay. All right, so if her hemoglobin was 12, she might feel tired all the time. She might feel rather lethargic. She might say, man, I don't really feel like doing this right now. I don't feel like going with you right now. I'm just kind of tired. Now, if you can make it an easy number, you can say, okay, say your hemoglobin was 10. 10 times 1.34 is 13.4. That's less than 20. All right, so that's why if your hemoglobin, you have iron deficiency anemia. If you're anemic. If your hemoglobin level is low, you're not going to feel good. Now, you're going to need, now let's say, okay, now the last time my hemoglobin was done, I think, and I've got the sheet over there, it was 15 point something. All right, so say my hemoglobin is 15.5. That's my number. Say 15.5. What is it? 20.77. That satisfies the cells, right? That satisfies the cells. Okay, the cell. Okay, so I should feel fine. I shouldn't complain. I shouldn't gripe. I should feel okay. All right, so that would be the deal right there. Okay, now, okay, 1 gram of hemoglobin. You need to remember this. Therefore, 15 grams. There's an average of about 15 grams of hemoglobin per. Therefore, 1.34 times 15 is 20.1 mLs of O2 per 100, and that satisfies the system. That makes the system happy. Attached oxygen is no longer attached to what? Attached to hemoglobin. It's no longer a free gas, and therefore it doesn't affect the partial pressure. So there we have that. PO2 is the most important partial pressure that determines how much oxygen combines with hemoglobin. The partial pressure of oxygen is very important in determining how much oxygen combines with hemoglobin. And so at that point, and let's see, I think this is going to get us down. There's HbO2. That HbO2 is known as oxyhemoglobin. Oxyhemoglobin. And we're going to mention next time what causes it to release its hemoglobin at the tissue level. It's a pressure thing. It's a pressure thing for the most part, and also some enzymes down there. Let me mention this we'll go real quick with this. When blood reaches tissue, 3 factors make it split. 1, low O2, oxygen separates. 2, acidity. At the tissue level, there's lactic acid. Remember lactic acid for muscle contraction? That plays a big role in making oxygen split. And then there's another thing down there which we don't worry too much about. Is this one on that well? It goes on and on and on. It's the temperature, the metabolic. We'll go over this again next time. We'll finish up with respiration next time now. We're going to finish up with respiration. I believe we said our test would cover heart and respiration, didn't we?